Everybody, it's Thursday, April 23rd. Hope everybody's doing well. Today I'm going to basically show a couple problems. Pretty much finish up this chapter. This problem says find the zeros of the polynomial function, and the function is equal to x squared times the quantity 7x plus 2 times the quantity x minus 3 to the fourth power. So you got to find the zeros of it and then state the multiplicity of each one of each zero. Well, it's already factored for us, so to find the zeros is going to be pretty easy because it's already factored for us. So to find the zeros, I'm going to set x squared equal to 0. I'm going to set this factor, 7x plus 2 equal to 0. And then I'm going to set this factor, x minus 3 equal to 0. And then solve for the variable in each case, and those will be our answers. Those will be the zeros. So x squared equals 0, hit both sides with a square root. The square root of x squared is x, and the square root of 0 is 0. So 0 is a 0. It is an answer. It's crossing the x-axis at 0. Another 0, x-intercept, solution, change sides, change signs. So we have 7x equals negative 2, change sides, change signs, divide by 7, x is negative 2 sevenths. There's another answer, another 0, and then change sides, change signs on this one, and x equals 3. So those are the zeros of this polynomial function, and then it says state the multiplicity of each one, of each answer. Well, the multiplicity of this answer is going to be 2. So multiplicity of 2. Because, and how you get the multiplicity is you just look at the exponent on that factor. So the the exponent on this guy where we got this answer was a 2, so it has a multiplicity of 2. Negative 2 sevenths, what is its multiplicity? Well, its multiplicity is going to be the exponent on that factor. Well, you don't see an exponent up there, so what exponent is up there? Well, it's a 1. So it has a multiplicity of 1. And then this guy, x equals 3, is going to have a multiplicity of 4. So you get your multiplicity by whatever the exponent is on that particular factor. So x equals 3 has a multiplicity of 4. So 0, negative 2 sevenths, and 3 are the zeros of this polynomial function, and 2 is the multiplicity of this answer, 1 is the multiplicity of this answer, and 4 is the multiplicity of that answer. And you get your multiplicity answers by whatever the exponent is on that particular factor. So that's that problem. And then I have another problem I was wanting to show you. Synthetic division. I've shown several problems on synthetic division in previous videos on this chapter, and but I think I skipped this problem, so I'm coming back to it, and it'll say something to the effect of use synthetic division to determine if negative 4 and 2 are zeros of this function. And it's 3x cubed plus 11x squared minus 2x plus 8. And then it says, of course, show your work. So use synthetic division to determine if negative 4 and 2 are zeros of this polynomial function. Well, anytime you use synthetic division, everybody has to be invited to the family reunion. So, make sure everything's in the correct order. It goes x cubed, x squared, x to the first, constant. So it is going third cousins, second cousins, first cousins, constant. Everybody got invited to the family reunion. If anybody of those, would have got left out, say there was no x squared term, then you'd have to put a 0 in that slot to hold that place value. But everybody got invited, so I'm going to say 3, 11, -2, 8. And it's wanting us to see if -4 is an answer to this polynomial function, to see if it's an x-intercept, a 0. Well, what you're going to do is you're going to do your synthetic division, and if you get 0 for your remainder, well then yes, it is going to be an answer. It is going to be a 0 to your function. If we do not get 0 for a remainder, then our answer will be no. So we do our synthetic division to test out to see if -4 is an answer. Bring down the first guy in the ball game. It's a 3. Multiply and add, multiply and add, multiply and add. -4 times 3 is -12. Add 11 plus -12 is -1. Multiply -4 times -1 is +4. Add 4 plus -2 is 2. Multiply -4 times 2 is -8. Add 8 plus -8 is 0. Of course, the guy in the end is our remainder. We did get 0 for a remainder. Since we got 0 for a remainder, that means yes, -4 is a 0. It is an answer to this function. It is an x-intercept, because answers, x-intercepts, roots, and zeros are all the same thing. So this function would be crossing the x-axis at -4. Then we also have to test 2, and to test that real quick, we do the same process, except where we use 2 out here, obviously. Everybody got invited to the reunion, so 3, 11, -2, and 8. Bring down the first guy in the ball game. That's a 3. Multiply and add, multiply and add, multiply and add. 2 times 3 is 6. 11 and 6 added together is 17. 17 times 2 is 34. 34 plus -2 is 32. 32 times 2 is 64. 64 and 8 is 72. We got 72 for a remainder when we tested out 2. So we did not get 0 for a remainder. So no, 2 is not a 0. It is not an answer. And it's only going to be a 0 to your polynomial function if you get 0 for a remainder. If you do not get 0 for a remainder, it's not going to be an answer. It's not going to be a 0. And that's what I got for you today. Have a great day, people.